Okay, so I've done these items before in the short course and in the previous CSWA. There were examples. There were some issues with the later ones. So just to update and kind of revisit the process, we'll bring them up to date in 2017. So on this, kind of reading down through the instructions. I've given you a material of the titanium Ti5 Al2.55N. Origin is at the center of the 22 diameter hole, so that is in the middle. And then we're going to verify the results. So since I have my previous results based on that information, we will we'll pick those out. And then, again, with the CSWA, one of the things is that question 1 may be what is the center of mass. Question 2 is what does it weigh given that it's titanium. And then question 3 is change from 80 to 100 and give me the new mass. All right, so going through that process, we need to pick out our starting point. So our strategy is to start drawing individual pieces and extruding them, or do we want to use the contours and regions? So identifying what is going to be helpful as contours and regions, if I can draw as much of this sketch as I can and then share those contours, share those regions between features, I'm going to be able to save a little bit of time. As far as things like baseline dimensions, is everything coming off of one datum? In this case, we have a chain dimension, and I think on the very first video this kind of threw me because you're having to search through kind of this jumbled mess. And one of the things to keep in mind is on the exam, they're going to give you maybe this view with a few dimensions. The front view will be down here, the side view will be over here, top view, however it cycles through. And you may have dimensions split between views, so you're trying to identify where those critical dimensions are coming from. So in this case, because the chain dimensions will usually throw me, those are something that I look for. So the 8, the 13, and this 14 are what's going to give me the overall height of the last block. All right, so just kind of going through that initial thought process, trust your instincts, look at the part and go, this is where the origin is at. So I need to start there. If I miss that origin, and what did I give you is at the center of the diameter 22 hole, top side. All right, so if I start this sketch and it's not here, it's my origin is down here, that's an indicator I would have to generate a coordinate system and then change to that coordinate system to get my my center of mass. Total mass, not going to be a problem. So if all the question is asking for all the way through its progression, or it's one question and it says what is the mass, it'll typically say put the origin anywhere you want. Origin's not set. All right, so we'll fly this out. We are in metric, so file new, part metric. If you have those templates set up to where you can jump right into metric, it's one less step, it's one less possibility. And I will say that my experience with the exams, they're metric. It's a worldwide exam. It's an international exam. It's metric. All right, so I'm going to go into the top plane, and we're going to see what this generates, because looking at the isometric and not having the top view or side view, but what would generate this this angle is that what did I just tell it to sketch on? The top plane. All right, so my decision is that if I draw this up and down and it goes to isometric, I'm going to be rotated, whatever that would be, the 120 degrees. The legs are going to be coming out this way. All right, so I'm making some assumptions as I built this out. So that brings up another good point: is did I take any pictures of this? All right. So it built out the way they built it out. And the coordinate system somewhat takes care of that as well. All right. So if we've looked at the drawings and we've identified the orientation, we need to build it in that orientation, build it to that geometry. So we said the 22 diameter, and then because I am going to be able to mirror some of these, it's going to be a horizontal infinite length center line. Come off of the geometry. I'm looking for those perpendicularities. Kind of help me out. And I do want to watch out for that midpoint that just showed up. And because the midpoint is actually there, it's probably not a number I want. I really don't want those relations to start catching me, at least not that soon. All right, a few dimensions. And then we'll watch for the angle, 16. The outside leg was 80. Oh, nice little movement there. Let's see, the width at the back is 15. And then, let's see, the overall was 40 from the step, and then somewhere we need to position that. Alright, so now we'll get back to the coincident. The issue would be then is, was that actually centered? Alright, so there's no center line symbol and there's no 20 millimeters telling me that it's centered. So this is probably something that threw me last time I did this, but we will go back and see. So we'll start with the 20 millimeters and we'll build out from there. The outside face, so this is going to intersect, is 35. And then I can do a quick check. If I go to the isometric view, that's looking pretty much like the drawing. All right. And then we had 60 degrees between.
That one dimension is supposed to be 15. You got 60. You can't quite read it.
Oh, yeah, it is 15. Thank you. See, I'm already trying to sabotage my exam. Got the 15 over here. Should have.
That brings up a good question.
Sure.
So that'll happen, right? So you'll miss a dimension. You can't read it yet.
No, their prints.
They make it pretty good.
Their prints are pretty good. They're not putting. I'm going to say that they're not going to throw chain dimensions at you. They're not going to throw fuzzy drawings like I do at you. So.
All right.
And then hopefully, I'm pretty sure there's not any missing dimensions as well.
Well, I think they'll all be there. It might just be hard to read.
No, that's one of the traps. That is, are you paying attention to what they're giving you? So when I mirror this, that gives me the geometry, and we can do a quick double check. And then for picking up our edges. So that will go all the way, that will go part way. So features doesn't really matter as far as directions. So again, I said top side, and that was one of those items that I'm drawing it on the top plane. Do I want to go through the math and reverse the direction? Is that going to help me? Well, as soon as I do that, the 20 millimeters overall, I've got to tell it to go 8 millimeters this way and 12. Am I painting myself into a bigger corner, or do I start back? And then there's the other thing is if you start second guessing everything, then that's all you're going to do the entire exam. So you pick one and then you decide to live with it. So I'm going to go ahead and bring this up. We're going to expand out. Go right back in and pick up the other geometries, and then this one goes up 20. All right, so that was to the leg, And then what I might do here is, since we have the 8 millimeters, the 13 millimeters to the center, let's see if we can cycle that through. All right, move over a little bit. Nope, not going to cooperate. All right, so the 13 to the center of the hole, and then 14 above that. And then I have to make a decision on what to do with this piece, because the 20, we said this would be 12, but the hole center is actually at 13. All right, so coming off of that face, or do I just go ahead and say I can sketch on the bottom, and I can use that that geometry. Go back into my wireframes, pick up something collinear or coincident. Make sure that we cover those relations, that all of the sketches are fully defined. And then when we extrude, we have to reverse it. We can do the 8 plus 13 plus 14. And did I miss one? Yeah, I missed one. So plus 14, 34. So fillets, I'm not worried about the until we get towards the end. And then one of the things that I don't remember, but I don't think that they do all of this 3 fillets coming together thing, because, well, as you're going to see, it was challenging the first time we did it. It's going to be challenging again. Okay, so we have a diameter of 12. And it's 13 above, and then vertical to the origin, and then that one gets extrude cut through. Alright, the ones on the side, we will we'll sketch in place, and I can't say that I remember there being a lot of hole lizards, so I'll set those to equal. All right, so 5 millimeters 4 places, and then 10 millimeters 2 places. All right, so got a little ahead of myself. All right, so off of center will be 14. All right, one moves, the other one doesn't. That tells me that I need to put in a horizontal. From the end, then, we have 10 millimeters. All right, we said that there's going to be 5 and 10. So just that normal kind of process of elimination is we're going to get this thing to go fully defined, just taking it step by step, and then the chain dimension of 28, and then 25. All right, we'll extrude cut those through. Up to next. All right, and then do I want to redraw that? No, not really. So we're going to identify the plane. And under the pattern, you're going to be able to find the mirror features. Mirror that feature and have the same geometry. All right, so let's put in the easy fillets. 3 millimeters, except for the outside, is 10. So what I would expect. So let's see, that one went to 10. And then I don't see the other, so we'll go to 3. All right. So maybe the internal, the outside, we have all of those geometries. All right. So I don't remember the questions getting too crazy on all of these intersecting fillets. This one, is more about paying attention. So as I add these items, I'm going to break them into several steps because I know where these three corners come together. That is going to be some fairly complicated geometry. All right, so it's not showing an up and over. So let's do those two, and then we'll double check the order. So 3 millimeters, and then the last one, we'll see what it looks like in a vertical. All right, because there are some strange things that can happen. That would be kind of the preferred result. Let's see, it's putting that right at my timer. So let's see what happens if we were to reorder some of these. No, I'm not going to get the interesting result with that one. Alright, so in the previous video there was one that went like all the way to the top, or there was some strange kind of solutions. Alright, but the main thing is that you're prepared to make those adjustments, reorder the fillets, and my first instinct is just to put the fillets on all of the edges and tie them all in at once. And if I was just designing this, that would be okay. Because of the exam, take a few that you feel confident will solve, and then go with them. All right, so we've gotten to this point. I feel pretty confident in my design. Matches the drawing. Haven't missed too many dimensions or added a millimeter here or there too bad. So I don't see titanium in the list. We're going to edit the material. We'll collapse the steel, titanium alloys, and we had 5AL 2.5N and annealed stress strain. I think that was it. Oh, there it is. There probably isn't, I haven't compared them, but let's go ahead and take a look. Mainly it would be the density, mass density, kilograms per cubic meter, 4480. 4480.0001. Yeah, I don't know. All right, so the SS is stress strain. If it's called out for that, pick it. If not, keep looking. Take another 30 seconds, scan down through the list, and make sure that there's not another entry somewhere. We apply that, and then close it. It changes color. It shows up titanium. And then to actually get our data, we're going to evaluate mass properties. And my initial, there's my center of mass. And based on the titanium, this weighs 291.417. And previously, for the 80 millimeter leg, I got 365, so sweet. What did I mess up? That's a little scary. Alright, so are a little bit closer. So 35 was across the front. Oh, it was across the front. I added it on the back. So let's make sure we can edit back in there. Okay, what am I in? Oh, I'm in the, alright, so drew the 35. And at this point, I don't know, it was across the front, 35. And then guess what? That's too long. Right, because the cuts, the mirror, let's see which one. Oh, that was still in the features, so cross extrude 3. Have to go back and edit. Alright, so being able to identify those connections. We have the top view. Alright, so it updates. Error. I'm expecting the error to be on the fillet. And then I'll try not to stop the recording. Alright, so edit the feature. Now there's missing edges because I had that across the face. That should have been a clue. Alright, so I can either delete those or accept the fact that there's not edges. And then there's that radius that I was looking for. Alright, so it kind of extends all the way up the edge of the part and rotates in. And that is right at the Alright, so just reordering the fillet can help with that selection. Alright, so the fillet comes back. Now that edge is kind of there. I wonder if we're going to put one more in there. So I'm spending a lot of time. That's an interesting fillet. All right. It's a little scary, but again, I'm not expecting the fillets to be that complicated on your exam. So if you find that you're like I'm doing, obsessing over the fillet, then we'll double check. So mask properties. If and basically what happens is depending on how the question is phrased, if they give you 4 choices and none of your 4 choices are within a couple of grams, then that should be an indicator. Maybe I should go back and double check my dimensions. All right, 339, and I just said that previously I had 365. So I'm going to say those fillets are still causing me no end of problems. All right, so one more check. We had the 40 millimeters. There was no center line. Nothing to pick that one out. All right, so even from version to version, may have to go back and find the short course one and open it up and see what I got on that. See if it's handy real quick. No, I'm not sure what I did with it. Okay, so go back into the mask properties. Oh, there they are. Well, guess I shouldn't click out of those. All right, double check, 0.004 grams per cubic millimeter. And I had 365 with 81,507. So somewhere I lost a little bit of volume. Both sides are correct. And it gave it as a diameter. So
you're too small.
Yeah.
Big vertical hole. Sure. Is that a 12 diameter? Yeah, what's the diameter? 12. Bigger than that? Not that one.
Diameter 12.
That was 12.
So interesting. Oh, I did not include the last ones, but that would have made it lighter anyway. So if we get rid of those,
right, 60 degrees inner parts of the two.
Well, 30 degrees because I went to the center line. All right, so you guys tell me what you get, and we'll double check the.
Yeah, just check the overall length of the parts.
There it is. 80 to the outside or 80 to the inside.
All right, that's it.
All right, and that's just how easy that. So in this one, I will try to put those back. All right, so now with the luxury of having my previous model, 362, that sounds a little bit closer. 365,
There you go.
within a percentage or so. All right, so it could still come down to fillets or to some other mass, but I'm within a couple percentage points. All right, so then the question going to 100 millimeters on the leg. Make sure that you rebuild. Oh, and then we didn't do the center of mass on this one, so let's make sure to pick that one up. All right, so the 100 millimeter leg, we got 478, and I go back into the mass properties. Either that or 418. It must be 418 because that's pretty darn close. All right, so setting up for the center of mass. If I do the mass properties, next item down is center of mass, x 4.777. At least some of those, 10.024 z value. All right, and I have no idea where that's pointing to. All right, so under your reference geometry, go back into the features, find the reference geometry. We'll set up a coordinate system, and well, let me have the center. Now it's really looking for a point. So my x, y, and z is in same orientation as the reference triad. So since I don't have geometry that I can build a coordinate system out of, what I'll typically do is a couple of lines that are my x and y. All right, so it gives me a point for the center of the coordinate system, which is the intersection, the x-axis, and the y-axis. All right, being able to manipulate those. And, well, since I manipulated those out, let's go ahead and clear the selections. I was still staying in. And then we will reverse one. All right. So x, basically if we rotate x, y, and z over, it's still in the same basic orientation as the reference triad. Interesting. All right. And then we'll go back to the evaluate one more time, mass properties. And that's not even close to what I got before. Nice. So I had a center of mass previously of the x of 1.78. Oh, no, it's millimeters. And 0.022. Z of 0. Z makes sense. Oh, and guess what I didn't do? What I told you not to forget to do. Change your coordinate system. So they changed. 2 millimeters, 477. Still not in the range of what I got before, so now I am concerned. All right, so tell me which ones worked out better for you. I'm gonna have to take the pictures down and figure out which ones are gonna work. All right, so example 1. So good examples of what can go wrong, or I got to go back and watch the video and see what I did. But all of those little items will add up and compound. All right, so 13 off of the face on center line. Double check the numbers: 12, 28, and 25. 5 and 10. Yeah, I got nothing. And 14. So at least there's history where I can go back and watch the previous video and go, what the heck did I do? All right, so let's pause this or go ahead and finish this one here, and if we have a resolution, we'll let you know. Okay, so take 2. Go back into the boss extrude 3. I did this math twice, maybe 3 times, but we'll go again. 8 plus 13 plus 14 goes to 35. So I kept adding the 12. and kept getting 34. And in fact, it is 35. We go into the mass properties, 365, 100.153 grams. That is what I got previously.